Hi, I'm Andy from KRUSS, and today I'd like to talk about Tensiio. Tensiio is KRUSS's new best-in-class tensiometer, designed to make lab work as convenient, flexible, and time-saving as possible. Now, this video will be the first in a new series all about Tensiio, where we're going to take a closer look at some of the different measurements that Tensiio can offer, and how they are used in all sorts of different applications, like dispersing of powders or pigments, the absorption of liquids into porous materials, the wetting of fibers, formulations of coatings. Even we can use the measurements for things like tracking plasma activation of a surface or assessing adhesion strength of adhesives and things like PSA. But before I go into detail about Tensiio here, we first need to talk about what is tensiometry and what can you actually use a tensiometer like this for. Now, KRUSS has a long history in this field, from our very first torsion wire-based design developed back in 1925, to the world's first digital tensiometer built in 1975. And many will be familiar with our long-standing flagship, the K100, which has been a staple in lots of labs for the last 20 years. Now, to be specific, tensiometry is about the measurement and analysis of interfacial tension between two fluids. Now, while early tensiometers were designed specifically for that purpose, the integration of new digital technology has transformed these devices into incredibly versatile lab instruments. And it's this flexibility why you can find tensiometers in research labs throughout an impressively broad range of industries, from coatings and paints to personal care, construction materials, energy production, or even aerospace. They're also a staple tool in many universities where they have the dual personality of being both for research and for teaching. Now, I've talked enough about history. I think it's time we take a look at Tensiio itself and we see what new innovations lie inside. Straight away, just looking from the outside, it's clear that Tensiio has been designed from the ground up to be ergonomic and easy to use, and is a perfect fit for any lab bench. It has a very small footprint, which is unobtrusive, but still you get a lot of room to work. You can open the doors up really wide, and you can gain access to the sample chamber very easily. What's more, from the back side here, we can take off these panels, and this gives us a little bit of extra room in case we need to attach something else, like for instance, if I want to put in tubing for a thermostat bath. Here at the front of the device, we have a multifunctional dial, which you can use to control the position and the movement of the sample stage very accurately. And at the top, we've added a 7-inch touchscreen panel that you can use to control all the different functions of Tensiio, as well as monitor the live readouts from the high-resolution force sensor or the other environmental sensors. Now, if we look through some of the functions, you can see I can control the sample position, lighting of the instrument, or if we go into this setting here, Tensiio has an inbuilt electronic bubble level that will tell you if the instrument is level or not. And when it's not, it also tells you how you can adjust the feet to bring it back to level. Now it's telling me I need to turn this foot this way. And now it's green again. We've also added at the back of Tensiio a USB hub where you can connect all different kinds of KRUSS accessories or accessories for anything else. This USB hub will be directly connected to the PC, so you can use it to tidy up your lab desk and connect other USBs that may be from different devices, all running to one PC with one cable. Moving to the internal components of Tensiio, the instrument has been built with a modular platform in mind. And that lets you exchange all sorts of different components. For example, I can take something like this. This is a Peltier temperature control stage, which lets me not only heat, but also countercool. And if I want to change this, I can take off the standard table here with just a single screw. And I can put in the peltier. And now I could feed the tubing through one of these side panels if I needed to. Another option is this. So this is a camera module for Tensiio, where we have a camera and a light source combined with a sample table. And this is a pretty exciting innovation because this is the first time that KRUSS have brought together the core competencies of optical image analysis and force-based analysis. And this opens up a whole new range of possibilities for Tensiio to make all kinds of new sort of measurements. There's also a wide selection of different attachments that give you access to different kinds of measurements. So we can take something like this. This is the typical Denoy ring that would be used for measuring surface tension. Or we can switch to the Wilhelmi plate. Or I can also use Tensiio to characterize not just liquids, but solids. So I can take something like this here, which is a Washburn cell. And it's actually used for characterizing the wettability and the dispersibility of powders. And if we want to put these into the device, it's pretty simple. Just open the door. Or I can switch this back. Now I'm ready to measure surface tension of my resin, or of my ink, or of my paint. And of course, it wouldn't make sense to talk about a tensiometer without mentioning critical micelle or CMC measurements. And for Tensiio, we have this, which is a CMC dosing unit. So you can use this in connection with Tensiio to change the concentration of a sample inside the device. So with a normal CMC measurement, you would have to make a new sample for each point of the measurement, and this can take many hours. With an automatic dosing unit, you can have this completely automated and you're not using up the time of the person. So they don't have to sit by the instrument and change the sample every time. It will change the concentration. It can either dilute or concentrate your solution. Now, I've talked a lot about the configuration and the flexibility of Tensiio, but one thing that's important to think about is also how the history of a tensiometer is very closely bound to the history of KRUSS itself. So naturally, when we release a new flagship design like Tensiio, we make sure it has all of the best specifications we can give it. So not only the sensitivity of the force sensor, but also things like the precision of the movement of the sample stage. So not only how quickly it moves, but being able to very precisely detect its position. We can show that with a quick example. If I take something like this sample attachment here, this would normally be used for some kind of solid sample, like a plastic or something. Here I've attached a small scalpel blade, a knife, and I can stick it into Tensiio, like this. Then I can take something valuable like a smartphone and lay it just underneath. Now, if I bring the two very close together, we can see just how precisely Tensiio can recall the same position. Now, the scalpel is just a tiny fraction away from the surface of the phone. I can still move the phone. It'll still move without scratching it. And then I can go into the screen and I can save this position. Okay. Now if I bring the phone down again, I can now tell Tensiio to go back to that position, and I can trust that it's not going to scratch my phone. Right. And again, if we look, it's just that same distance away, but without actually touching the phone. And again, I can move the phone around and it's not going to scratch anything. So I've very, very precisely recalled exactly the same position. And that is the kind of precision that you want for a device like this. And now we come to advance. So anybody that already has a KRUSS instrument will be familiar with this software. We use the same base software for all of our instruments. And if we look here on the home screen, we can see all the different kind of measurement methods that are available for specifically this Tensiio I have here. In this case, I want to look at doing a surface tension measurement. So I can click here and I could open using a new template from this. This is just the standard template that Advanced comes with. In this case, I'd like to actually open an older measurement. So I'm going to go back into my folder here and down to a measurement I already made. Now, when you open a measurement up, Advanced guides you through the logical progression of an experiment. You start at the top left with giving some details about the instrument and the measurement itself, maybe the sample you're measuring. Then you move to the right and you work your way down through the automation program, which tells the instrument how it should measure. You have a readout of the live data here. And on the right side here, you have all of the controls that you saw before on the touchscreen. So you can control all the different functions of Tensiio directly from the software as well. If we go further down to the bottom, now we have everything that comes out after a measurement. So we have all of the measurement results plotted here as in a table and here on a graph. And down here we can see now the summary. So in this case, I told Tensiio to take several measurements and take an average. So at the bottom, I have that average surface tension value, in this case for water. And to the right here, I've set up a validation step. Now, normally surface tension of water should be about 72.8. In this case, we were happy with 70. So we set a validation step of 70 or higher, and we can see it's lighting green because my surface tension was within that range. If I go now to the very bottom, when my measurement's finished, I can even export the results directly to Excel or as a PDF. So I hope you've enjoyed this first video. This is going to be the first, as I've said, in a whole series of videos just about Tensiio. In the next videos, we're going to look at getting a bit more hands-on and actually making different measurements with the device and seeing what the data from those measurements really tells us for different kinds of applications. So thank you very much for watching. Bye now.